Right. So look at this problem. A wheel with 10 metallic spokes, each with 0.5 meters long, is rotated with a speed of 120 revolutions per minute in a plane normal to earth magnetic field. They have given the magnitude also 0.40 Gauss. What is the magnitude of induced EMF that we have to find out? Well, so let us try to visualize the problem first. It is a spoke, and it is a wheel with 10 metal spokes like this. 10 metal spokes will be there. Don't count this, it will be around, we don't know what is the number, but we will assume here we have 10 metal spokes. So let me choose this metal spoke, and each with a length of 0.5 meter tall. So this is going to be 0.5 meter length, and it is rotating inside with a velocity 120 revolutions per minute. 120 revolutions per minute. And we know very well the induced EMF for a rotational conductor is given as half BL square omega. They have given every information. Thing is, we have to substitute back to here. What is that? Half into, what is the B? They have given 0.40 Gauss, but we have to substitute here in the SI unit system. So 1 Tesla equals to 10 to the power of 4 Gauss. Hence 1 Gauss equals to 0.4 into 10 to the power of minus 4 Tesla, multiplied by, what is the L? 0.5 meter. So 0.5 whole square multiplied by, what is the omega? Omega is nothing but angular velocity, which will be given by the formula 2 pi n divided by t. So number of rotations, n stands for number of rotations. How much? 120 divided by, what is the time? 60 seconds. Therefore it will gives you 4 pi. So that's what we have to substitute, 4 pi. Now thing is, this is the, by simplifying this one, you will get the induced EMF. Now what is the total induced EMF? What is the total induced EMF between the center of the axle and upon the rim? So by connecting the center of the rim and this axle and this rim, we have the 10 spokes. Then what is the induced EMF, total induced EMF? Will it be 10 times of this value? No, it will be this value only. How many number of spokes may be present over here? Because these are all conductors are connected in parallel way. Why I can say it is parallel? Because all the spokes initial ends are connected to axle. All the spokes final ends are connected to rim. And therefore these are all rods are in parallel circuit. These are all are connected in parallel way. So we know very well, whenever the several batteries are connected in parallel circuit, parallel way, such that all have the same EMF, then the net EMF is equals to individual EMF itself. Therefore, if I simplify this one, I will get the sum result, and that's going to be the total induced EMF between the axle and rim of this wheel. Okay, right? So this is what the induced EMF concept. Now shall we move on for next problem? Right. Sorry. right? So let us do this problem. A metal rod of resistance 20 ohm is fixed along the diameter of conducting ring of radius 0.1 meter and lies on xy plane. There is a magnetic field of B bar equals to 50 Tesla K cap. That means it is acting along the positive z axis. The ring is rotates with an angular velocity of 20 radian per second about its axis. An external resistance of 10 ohm is connected across the center of ring and rim. Then what is the current through the external resistor? So we have to find out what is the current in this circuit. That's what we have to find out. So let us try to visualize the problem first. This is a ring. And a metal rod of resistance 20 ohm is fixed along the diameter. That means this is going to be the metal rod and whose length is, so it is like radius 0.1 meter, so the total length is 0.2 meter. The length of the rod is 0.2 meter and at the center its distance is 0.1 meter. Okay, now it is kept in xy plane, hence I can keep like this. This is kept in xy plane. A magnetic field of 50 Tesla is acting along the positive z axis. That means here I have a magnetic field of 50 Tesla whose direction is out of the plane of a board. The ring is rotates with an angular velocity of 20 radian per second. Let me assume the ring is rotating here with an angular velocity of 20 radian per second. So like this it is rotating. And an external resistance of 10 ohm is connected across the center and ring. So it is like this. From here, one external resistance is connected like this. Now, what is the current going through this external resistor? That's what they are asking to find out. Thing is, here this total conductor whose half of the length, half conductor length is 0.1 meter. The magnetic field intensity is 50 Tesla, and it's moving with a angular velocity 20 radian per second. So whenever one conductor is rotating inside the magnetic field, what is the induced EMF? That will be given by half BL square omega. Now half into what is the B? 50 Tesla. What is the length? 0.1 meter. So 0.1 whole square. And what is the omega? 20 radian per second. So which is equals to 2 ones are 210 and totally 500 into 1 into 10 to the power of minus 2, and therefore we will get 5 volt. This is the EMF that generated here. Okay, now this whole circuit could be equivalently drawn like this. I mean, this arrangement can be drawn like this. How we can draw? Like this we can draw. Here, this and external resistor, all the three are parallel to each other. Now, how to draw this equivalent circuit? I should know what is the direction of induced EMF. I mean, I should know what is the direction of induced EMF. What is the direction of induced EMF? So, since it is rotating like this, the direction of magnetic field is out. So, therefore, I can assume like this. This is the direction of a magnetic field. This is the direction of a rotation. Therefore, this end I will have a more potential. This end I will have a less potential. How can I think? Like this I can think. So this is showing the conductor has a total resistance of 20 ohm. Therefore, it will have how much resistance? 10 ohm. It will have how much resistance? 10 ohm. So this can be assumed to be 10 ohm resistor. And so this end I am representing here with a positive plate. This end I am representing with a negative plate. And its resistance is 10 ohm again. What is the value? 5 volt. 5 volt. And external resistance of 10 ohm. They have already given the external resistance is how much? 10 ohms. The external resistance is how much? 10 ohm. Like this they have given. Now from this we have to find out what is the current that is going through the 10 ohm resistor, which is nothing but external resistor. Okay, so yes, let us do this one. Here these two cells having the same value, and of course they are parallel to each other. Therefore, what is the net EMF? That equals to 5 volt only. The net EMF equals to 5 volt. If I want to find out the current, I should know what is the net resistance. What is the net resistance? Even though these two cells have a same EMF, net EMF can be considered as a 5 volt. that of course. And then what about the net resistance here? These two are in parallel, therefore the total resistance could be 5 ohms, and that is in series with the 10 ohm, therefore plus 10 ohm, totally 15 ohms. Got my point? These two cells are connected in parallel way, therefore net EMF could be written as 5 volt. These two resistors are connected in parallel way, therefore 10 ohm, 10 ohm. When the two resistors have a same value and if they are connected in parallel way, the net resistance is nothing but half of the original, 5 ohms. And that is connected in series with the 10 ohm, therefore 10 ohm. Therefore, total sum equals to 15 volt. Now, what's the current generated here? The net EMF generated by the net resistance, which is equals to 5 volt divided by 15 ohms, and that is equals to 1 by 3 amperes. This is the current going through a external resistor. Okay. Okay, done. So, with this, we are going to end this session, and in the next session, we are going to start with the induced EMF generation due to the changing of orientation of a loop, and we will do some problems related with that, and we will carry on with the remaining topics. Thank you.